a measure of the adaptability in a chemical bond.
Okay, so graphing inequalities is going to make us go all the way back to grade 10. So in grade 10, you did a whole unit on graphing lines. Do you remember doing that? Okay, so this is the equation that I'm going to refer back to. Y equals mx plus b. Does that ring a bell? M is your, do you remember what it was? Slope. And the b was the, remember what that was in that equation? It was the y-intercept. Okay, on a line, when you do a slope on a line, it's a something over something. Do you remember that? Rise over run. If your slope is positive, do you know the direction your line heads? It would head uphill. And if your slope is negative, you would run downhill. Okay, so those are some things from grade 10. Also from grade 10, you had lines that went flat and lines that went straight up and down, so horizontal and vertical lines. Do you know what letter a flat line would be? So would it be x equals a number or y equals a number? Y. Y is always the same. Think about it. Every single where you go on that line, what's the same? The height, the y. And then this would be a x equals. Okay. Let's see if we can do this. Okay, number 1. Y equals mx plus b. Okay, so I wrote a 1 there. Instead of just an x, I wrote a 1x so that you can see what is the slope? 1. It's the slope of 1. So what I'm going to do is I'm going to start at 5. And then to do a slope of 1, what is 1 as a fraction? 1 over 1. So I'm going to go up 1, right 1, up 1, right 1, like a staircase. Staircase. And don't draw your line. So that's going to be my line. But this is the thing that's new in grade 11. This is not an equal sign. This says less than. So I can't be equal to this line. So I'm going to draw this line as a dashed line. Saying I'm not allowed to be equal to the line. I have to be less than the line. Okay, so here's what I want you to think about next. You have 2 options, the thumbtack or the penny. Which side of that line would show me being less than it? The tack or the penny would be less than that line? The penny. Okay? So here's what I'm going to do. I'm just going to draw some arrows to say this direction is facing less. Okay, the second line. I'm going to draw a y-intercept at 1. Y-intercept at 1. And then -2 is the slope. But as a slope, you always want it as a fraction. So -2 over 1. You always need a fraction. So if there isn't one there, it's because it's over 1. So I'm going to be going down to right 1. You can do a few staircases if you want. Down, 2, right, 1. Down, 2, right, 1. Okay, what does this read as? What does this symbol read as? Y is what? How do you read that symbol? Greater than or equal to it. This time I'm allowed to be equal to the line, so guess what kind of line I'm going to draw? Solid. I'm allowed to be on that line. That's what it means. I'm allowed to be on it. Okay, and I have two options to be either on this side of it or that side of it. So which side would show me I'm going bigger than that line? I'm going greater than that line. The tack, yeah. That is heading bigger, in a bigger direction. So this is angling upward. So what are the coordinates that work? Anything in this zone. Anything in that zone or right here on the line would be a solution. So, can anybody name me a point that should work? Give me any coordinate. There's infinite answers here, but give me one coordinate that you would say is a solution. 3, 3. 3, 3 is a solution. So, if I plug 3, 3 in, is that true? Is 3 less than 3 plus 5? Yep. Yeah. Is 3 greater or equal to negative 2 times 3 plus 1? Is that true? Yes. Yeah. Okay. Name me a coordinate. So this, you don't have to do this, but I'm just showing you like what this is about. If you are questioning if you shaded the right part, that is a way you can check it out. So I for sure shaded the right quadrant area, if that's what's going on. What's a coordinate that shouldn't work? Anything. Negative 2, negative 2 shouldn't work. So if I tried that out, it might work in one of them, but it has to work, it has to work in both of them. Is this true? Is negative 2 less than, is this true? Yeah, that is true. Is this one true? This would be 5. Is negative 2 greater than or equal to 5? No. So that shows you why it doesn't work. And we didn't shade it because it doesn't work. Okay? So yeah, it was true for that, but it would have to be true for both of them. Okay, ready? I'm gonna make you tell me, would this be a solid or a dashed? What do you think? Line 1. This would be a solid line. This would be a dashed. And this would be a solid. Okay, and the reason is, if it says it is allowed to be equal to it, you can be on it. Okay, the first line is special. Multiple choice. Is it horizontal or vertical? X equals lines are vertical. So at 5, we're drawing a solid vertical. At negative 5, we're drawing a solid vertical. Okay. Okay, so when I'm teaching my grade 10s this, if you forget if it's vertical, here's what I always say. Draw me a coordinate with a -5x. So you can draw any coordinate. Oh, there's another coordinate with a -5 as an x. Okay, well, how are they lining up? They're lining up and down. Okay, which side of that line would you want to be on? Which direction shows me I would be heading greater than that line? Tack or the penny? The penny side is bigger. You're heading in bigger x values this way. Those x values on that side are bigger, right? Okay, number 2. I can't do anything right now because I don't know any info. So here's the goal. We want to make it look like y equals mx plus b. So we want y alone. So algebra, ready? Leave 3y right where it is. Greater than, the x stuff would need to go to the other side. So how do you write it on the other side? Positive 2x, because when you switch sides, right? The number was over here. I need to move it over to there. So it would be a +9. And Reese, what did I say about the kids yesterday? If we're going to do something here, you got to do it to every single one. Like kids, if you give them candy, you got to get them all the candy. Remembered? Okay, so I'm going to divide by 3. But like Reese said, if you give kids candy, you got to give every single one of them candy, or else somebody's mad. Okay? So here we go. Y is greater than 2/3 x plus 3. Okay, that is now something to know how to graph. Okay, here we go. The y-intercept is 3. Draw a dot. The slope is already a fraction, so it tells me to go rise 2 up, 3 right. Up 2 right 3. And we already told ourselves we're going to draw this dashed line. Up 2 right 3 dashed line. Okay, it says this symbol, greater than. So I either have the tack option here or the penny option on the side I want to be on. Which side looks like it would be greater than that line? The tack. Okay, so I'm going to just draw myself arrows that are saying head this way. All right, the last, bless you. The last one. Okay, ready? Keep the y stuff. But don't forget the y stuff says -2y. So keep the -2y. Less than or equal to. That x stuff I'm going to be moving. So when I move 4x, the number stuff is going to also have to move. And I'm going to have to divide by -2. And something crazy is going to happen, so don't go too far here on me on the writing. Okay, this is just a math rule you're going to have to remember. Sorry, I can't help you. It doesn't tie to anything. It's just a memory thing. If you divide or times by a negative value, your sign flips over. What? Okay. So I don't know how else to help you remember that. Just that's what happens. The sign flips over. Only, did you notice how I didn't do it here? Because I divided by 3, +3, so I didn't do anything different. But here, there was a flip. So this makes -2x, and this makes a +3. And if you're okay, I'm actually just going to write this over 1, so I just remember what to do. Because I always like my slopes as a something over something. Okay, the same y-intercept, 3. You're going to head down to right 1. And we already wrote to ourselves that we should draw this as a solid line. Okay, I'm also noticing that I should probably extend this one that I drew before, just to make sure that they are crisscrossing each other and stuff. So, just to show that all these lines do end up crisscrossing somewhere like that. Okay. And now I got to decide which side to be on. So after the flip, after this flip, now it's going to say greater than. Greater than. So which direction heads the greater way? Thumbtack. So I'm going to show some arrows. Okay, so what works? Do you know where to shade now that we have everything indicated? So I have to be above this one, above that one, and I have to be to the right of that. And do you see how this would stop like this as a right here? So any coordinate, obviously that would go on forever and ever and ever, right?